Okay, in section 2.7 we're going to talk about inverse functions. And so I want to say that the inverse function, or the inverse of a function f, is denoted by f to the minus 1, and it's read as f inverse. So this is the function that undoes f. So if you stick x into f, what's going to be spit out is f of x. And the point of the inverse function is that when you stick f of x into f inverse, it spits back out x. So that's f inverse of f of x is equal to x. Okay, so when you compose these functions, they undo each other. And the same holds for f and f inverse. So if I stick x into f inverse, then what comes out is f inverse of x. And if you stick that into the function f, what comes out is f of f inverse of x. And because these functions undo each other, what you end up with is x again. And so as an example, I want to kind of draw a graph of a function f and x. So let me just pick some x values and some f of x values, and then we'll draw the f inverse function as well. So let's say that f is a function where if I stick in -2, let's say maybe I get -1, and if I stick in -1, I get 0. And if I stick in 1, let's say I'll get 1. And let's say if I stick in 4, maybe I'll get 2. Okay, so this might be something that looks, the function f might look something like this. -2, -1 would be right there, -1, 0 would be there, 1, 1 would be right there, and 4, 2 would be something like right there. 1, 2, 3, 4, up 2, yeah. So let's say f looks something like this. So f of x looks something like that. And then I want to draw fx and f inverse. So I'm going to make another table over here. So if I stick in -1 in for x, f inverse will give me -2. So I'm switching the places of the x and y coordinates here. And if I stick in 0, I'll get -1, and if I stick in 1, I'll get in 1, and if I stick in 2, I get 4. So that might look something like this. And actually, I'm going to draw the line y equals x in green here. And we're going to see that f inverse should be the inverse, or should be the mirror image of f of x across that line. So, like I said, we have -1, -2. -1, -2 would be down there. 0, -1 would be right there. 1, 1 would be right here. And 2, 4 would be up here. And so the point here is that if your inverses of each other, you're going to be mirror images across the line y equals x, and that's because the inverse function is just flipping the x and y values of the original function in a sense. So the answer to the last question is that graphically a function and its inverse reflect over the line y equals x.